In this segment, we're going to look at how we specify the frequency and amplitude points to help generate and define the wavelet that we're going to use. So what you're looking at is the JTIPS wavelet menu. And we've seen this before, and we could pick the different standard types, Ricker, Ormsby, Gabor. We can save and restore wavelets as well. We can change all the parameters, the phase shift and like, and produce a wavelet. Now if I'm over here back at our Ricker wavelet, and I have a 40 Hertz wavelet, you notice this is the actual wavelet that's produced. And over here is our amplitude on this axis and our frequency values here, and shown again up top over here. So this is our frequency spectrum that for this wavelet we would expect to be this bell-shaped curve right around 40 Hertz. If I change this to 65 Hertz, obviously that value moves. So what we're going to do is look at how we handle the specified wavelet. Now this is a little bit unique. So on the specified wavelet, we specify a series of points, frequency and amplitude pairs. This becomes really valuable when we look at doing wavelet extraction from seismic data. But what I'm going to show you is how to do this in a general manner. Now normally, you could come in here and type values, and we separate them, these data points, by dashes. So our frequencies here are always in an ascending value. So we're going from 5.0 to 60 to 120. And our amplitude is at 0, 1, and 0. And that's reflected over here. Now this is obviously not horribly realistic, but it gives us a point to start. So these data points, you see these blue points over here, these represent these data pairs over here. So rather than typing those values in, which could be a real pain, quite frankly, we've created a simple way to interactively define these points. So we have a toolbar across the top that handles our points. When we click the arrow, that's a point select mode. What that allows us to do is grab any one of these points. When I mouse over it, you see the highlight. I can click it and drag it, and I can move it anywhere I want. You can see as we move it, this data changes. The wavelet, as it corresponds to that value, changes. Okay, so we've just put in a few points here. Now what I'm going to do is I want to add some data points to give a little more specificity to this particular curve. So I go to the icon over here that looks, this is add specified point. When I click on that, then I can just come over here and digitize on that screen wherever I want it. We're not going to worry too much about it. And I can plop in a whole bunch of those points. If I want to get rid of a point, I hit the delete button over here, and I come to one of these points and I hit delete, and it simply removes this point. This is pretty standard behavior in a lot of point and click type things. So I'm going to go back to my point select mode and get this, and I'm going to start moving these around. I'm going to move that point up. And now what I'm doing, again, is I'm defining a spectrum of my amplitude going from 0 to 1 and my frequency. And as I drop any of these, again, just click and drag, the resulting wavelet for these parameters is shown. Now, there are a few constraints on it. Obviously, I can't move this point below 0 or above 1. I can't move it to the left of the previous point or to the right of the next point. It always keeps it separated horizontally by at least 1 Hertz. And finally, the other constraint we put on this is our first and last point have to be 0 amplitude. You know, if you have this and you try to move it up and down, it won't do it. It's going to go along that axis. So if you need to put a point along there, you would just add a point at a low frequency here, and then I can move this around. So now I have this data complete. That's my wavelet. Now I can come over here, and it's like any other wavelet, and I can put a phase shift on it and see the phase. But the fundamental wave is defined so that it matches this current parameter. Now what I'm going to do is quickly pull up a seismic data, and we're going to go to Tools, Extract Wavelet. And we're not going to worry too much about the details of this. This is covered in documentation. But as we define our autocorrelation region for this particular wavelet, let me zoom around a little bit more so that we get it all in one window. Okay, we have this over here. This is the extracted content from all of this seismic data, and as we expand this for more traces, whatever it may be, this will update. Now I'm going to use that tool of the specified to go and create a wavelet that matches this information. So when I click it, I come over here, and this is that menu we were just in, and you see the red line drawn. I'm going to reset. I'm going to get rid of all the blue points so we can start over. And there's a little button there that says reset points, and I go back to just having 3 points in there. Now what I'm going to do, you see this red curve, again, is the same as this spectrum. I want to digitize to define something that has that similar shape. So I'm going to come over here to add points, and I'm just going to start adding. We don't worry too much about the details of it, because we can always add and delete more points. But you kind of get the general inflection points on there. Then I'm going to go back to hit the cursor, and I'm going to move this point up, and I'll move this point down a little bit. Oh. And you see this point's fine, and this one's going to grab that peak at about 58 hertz. If you want, we can drop down a bit. Okay, so now I have defined a wavelet, and you'll notice this wavelet creates itself automatically. Let me move this point a little bit back and forth, and you can see the wavelet changing. You can also see the values up here changing. So this is how we specify these points to create a wavelet. In this case, this particular wavelet, when we apply it to our synthetic, is going to be almost exactly per the data that we pulled out and auto-correlated. So that's the end of this video, talking about how we specify data points to produce a wavelet.